In last session, we discussed about lock modes and lock duration and concurrency, the types of concurrencies like pessimistic and optimistic, and the problems you're facing without with concurrency, due to concurrency, like lost updates or uncommitted, or we call it as dirty reads, right? And non-repeatable reads and phantom reads and so on. So let's continue our discussion on the locks. In this session, we're going to discuss about lock granularity. So it is pretty clear from the word lock granularity. What is meant by granularity? What it deals with? So at what granular level you can provide the lock? So this lock granularity deals about the granularity. I mean, at what granular level you can provide the locks. So for example, page, you can set the lock at page level, or you can set the lock at row level. Let's see the granularity, different granular levels at which you can provide the locks. The first and the lowest one is obviously row. For a row, you can provide a lock, and the next one is page. At page level, you can provide locking system. And in the same way, I mean, we have not had discussed about indexes, but you can provide locks at index level too, and you can provide table level, and you can provide extent, which is nothing but a memory location, a particular piece of memory. For a particular piece of memory, you can apply this locking mechanism, and you can set the lock at database level. If you see, all these things are the different granular levels at which you can set the locking system. And if you don't specify any locking system explicitly, then the system automatically chooses the appropriate lock granularity. If you don't specify it explicitly or externally, then it will take care of the lock granularity. As you can see, the row is the lowest source that can be locked. And the indexes, if you see the third one, the indexes, I'll give you a brief about index here. Index is nothing but setting a versioning number or setting a unique identifier to every row. So if you create an index for every row, it will create a unique index ID. So based on that, it will be ordered and filtered. The performance of that table or the select statements will be improved if you set an index on a particular table. So you can set to either row or index, and both are very similar one. At row level, I can say you can either specify row level granularity or index level granularity. Both are one and the same. Why? Because index are defined on for a table on rows. As I told you, row level granularity is the least one. The problem with the row level granularity is you can actually, what you do is you can set a lock for a particular row. For example, select start from employee ID where employee table where employee ID is equal to 1. You can set a lock for that particular row, and obviously the problem will be the rest of the data. The rest of the data in the table will be shared with the other guys. It can be accessed by other guys. Only one row will be locked and remaining data will be free. That's one way its advantage. It supports full level concurrency. The remaining data can be accessed by other applications. But the level of, if you see, it can hold only one row or a particular row that you specified in the select statement. And even though that is the least level of granularity, it supports full level of concurrency. So when the locking is done on units or disk space units, then we call it, or also we call it as extents in SQL Server concepts or database concepts. So if the locking is done at extents level, then we call it as extent granularity locking part. And it affects the concurrency, obviously. It controls. It if it controls or if it locks the huge disk units, then the data cannot be accessed by another transaction. It's simple. See, for example, let me take the pen here. If it is a single row in the full table, and if the lock is set on this one, the remaining data, this part and this part will be available to the other applications. This is available, right? So the concurrency level is pretty high. I mean, you can serve the data, the remaining data to the other applications. Let's say you have some 64 KB or 128 KB of disk units locked using the extent lock. So this complete data will not be available for any other user. It will not be available for any other user until this lock is removed. So that's the problem. If you set the lock at higher levels, then the concurrency will be pretty. It affects the concurrency part. You cannot go for concurrent users cannot access the data. So that means the row level locking maximizes concurrency because it leaves all but one row on the page, okay? And the least level is the top level, that is page level locking or table level locking, restricts the availability of the data and it will not provide access to the remaining users. But the advantage is the system overhead will be reduced. So the complete table will be locked and it will be in control of this guy. Until you lock this, no other user can be accessed. And you can also think about it. See, once it releases few records from this, there will be obviously there will be a confusion, right? I mean, while concurrent users are trying to access the same data. So keep in mind, to make it simple and short, the row level is the least level of granularity you can set, and the database level is the highest level of granularity you set, and you have 6 different levels of granularity, that is row, page, index, table, extent, and database. And you know, page, it contains the number of records, and row is nothing but one record, and index, you know, it's again index will be there per record, and table, you are very well aware of this, it's a complete set of table, and extent is a memory block, or you can call it as disk units, and database is complete database. You can set at any level, but row level, it increases the concurrency part, whereas database or the table level, it decreases the concurrency part. Okay, the next one is we discussed about log granularities, and you can sometimes the system jumps from one granular level to the next granular level. Even it can be set by us, or it can be automatic one. So why it jumps? What's the need for it, for the server to jump from one granular level to the another granular level? Let's say I have a transaction here. Let me take a pen. Let's say I have a transaction and it has so many select statements or so many queries, or I'm looping through a table each and every row and writing a select statement, okay, something like that. I have so many statements which is setting some let's say row level lock on each and every query. So when we have multiple, or I can say many locks of the same log granularity, let's say row, okay, if I have many row level logs in a particular transaction that are held, or I can say struck, then what the system will do is it will upgrade all the row logs, all the logs into one table log. So let's say transaction A, it is accessing a table and it set row level locking. Remember, it set row level locking, and for every row it has set some locking, and there are some 500 rows. That means 500 locks are set. Okay, so all the rows will form something around 500 locks, and if these locks are held at one point in the transaction, then what the system will do is automatically these locks will be upgraded to the next level, that is table level. So in short, if we can say if many locks are locks of same granularity or blocked or held during a transaction, then this database engine, SQL Server database engine, automatically upgrade these locks into a table lock. And this concept, this particular concept of upgrading to row level locks or multiple row level locks to one table level lock is called as lock escalation. Okay, lock escalating. It is escalating to the next level, that is table level here. So let's see how to set this, whether it is in our hands or in the hands of server to set the next level of escalation. Actually, there is a keyword in SQL Server which we can use to control the lock escalation path. That is lock escalation. So this is the one which you can make use of to set the lock escalation, and it will be like set lock escalation is equal to the value, whatever the value you want to set. For example, there will be three values you can set. One is table, or you can go for auto, or you can go for disable. So generally, when you set it to table, that means it will be automatically, all the row locks will be automatically escalated to table level. Okay. If you set it to auto, then the choice is with the database engine. It can pick whatever the level it want to go, or whatever the level it want to escalate all the all the row level locks to one higher level lock. And the third one is disable. If you set it to disable, then that's it. It will not take care of it. It will not do any job there. It will be disabled. All the 500 row level locks will continue in the same process. So how to set this one? As I told you, this is a table. I mean, this can be set at table level. Let's see how to set this lock escalation for a table. Let's say I have a table called T1. The syntax for this one is alter table name set lock underscore escalation is equal to the value, whatever the value you want to set here. You can, if you don't set anything, generally whenever you create a table, it won't be set, right? I mean, you're not setting anything explicitly, right? So the default one is table. So if you don't specify anything for the lock escalation, then it will take the default value as table. And let's see, let's try to set for a table, alter table dim product set lock escalation is equal to table. Or you can set it to disable. Let me set to disable. Already by default it will be table only, right? Let me set it to disable. The spelling is right? No. Incorrect syntax here. Alter. What is this? Can you check whether any spelling mistake here? All these things will form one. So this is how you have to specify it. Now this is the syntax for it, and if you observe it now, the table by default it was table level lock escalation. Now I change it to disable. So when a transaction is pointing or setting a row level locking for this table data in this table, then let's assume there are so many such locks held together, then it won't escalate to the table level. It will be as we disable the lock escalation part. And this lock escalation is very important concept, and no one in SQL Server except their masters or purely working on SQL Server looks into this lock escalation. But all the guys who are taking interviews will concentrate on this part, will ask a question from this for sure. So if he start talking about asking about locks, then for sure he will touch this lock escalation. So in simple form, if they ask you what is meant by lock escalation, you just need to answer like lock. If many locks of the same lock granularity are held during a transaction, then the database engine automatically upgrades these locks into a table lock. So this process is called as lock escalation. And this is how the syntax, if you ask for syntax, if you answer it properly, then the next question will be, what's the syntax? Alter table name set in parentheses lock escalation is equal to the value. The value, different values you can provide for the value here is table, auto, or disable. And this is the example for it. Till now, we discussed about lock modes like shared lock and so on. What are the different types of locks available, and how the granularity of each lock can be set. I mean, what is the level or granularity of different granular levels of the locks. And now let's see how we can make it affect in the, I mean, we have not yet set even a single lock, right? How to set these locks and how to make it work. We have to make it work in SQL queries, right? That's the ultimate goal. So we call it as locking hints. Locking hints means the one which affects the locking functionality in SQL queries or transact SQL queries. There are so many locking hints, but the query, the syntax will remain the same for all the locking hints. There are so many, let's say, let me list out a couple of things. One is row lock, another one is page lock. Remember the spelling, it's not PAGE, page lock, and the third one is tab lock, that is table lock, and you can use DB lock and so on. You can set all these things whenever you are making use of it. There are so many locking hints. Let's see a couple of locking hints here and how to give or how to make use of these locking hints to affect the locks in our SQL Server queries. And you can use combination of the locks, locking hints also. It's not like, oh, you have to use only one combination or one locking hint. You can use combination, but you have to keep in mind that combination should make sense. If it is sense like page will have tables, right? And page, it makes senseless if you go for table and page level locking as a combination, right? So let's see how to use this locking hint. The most frequently used locking hint is no lock. That's the first and foremost one people talk about. I mean, people uses it. I mean, the people who don't know anything about locking hints also will go for no lock, which means the no lock will be set. And let me show you how to do that. Select star from, let's say I'll take a table name, dim product with brackets no lock. So no lock will be set while retrieving the data. Generally, by default, locking mechanism of the SQL Server may set some locking for this. If you specify it explicitly, then it won't take any lock. So this is how you can make use of the locking hints. And let me take here, I'll try with row lock. So now the locking is set at row level. This is how you can set the locking hints. Now let's discuss about the different level of locking hints that are available in SQL Server. The first one is row lock. Generally, people uses this whenever, I mean, you know the row lock means. Generally, people uses this whenever they're reading the data or modifying the data. That particular row will be locked, and you can modify or you can read the particular data. And once the lock is released or once the transaction is completed, then that lock will be released automatically. So let me tell you one real-time example where we use no lock, but in particular, no lock will be used. For example, somewhere people are updating the records. Okay, on one process, people are updating the records or modifying the data, delete or updating. And if you want to see the data that is present in the table just for some other reason, by some other user or some other process, so people prefer to go for no lock, which will not impact the other transactions or other locking mechanism that is already placed on the particular table. So that's one example where we use no lock locking. Now if you see the next one, there is one more that is update lock, right? We discussed about update locks. Update lock, the keyword is UPD LOCK. So this is how you have to specify the update lock. Generally, update lock places update locks for each row of the table during the read operation. So for every row of the table, it will be set with the update lock. What will update lock will do? Update lock will work as shared lock until it reads the data, and when it starts updating the data, then it will become an exclusive lock, right? So that's the advantage of having update lock. If you specify it as update lock, then it will be shared lock until it reads the data, and it will become exclusive lock when it started inserting or modifying the data. And these update locks will be set for every row. So now if you see the third, if you go for table lock, TAB lock, then the complete table will be held until the end of the transaction. So it will be it will place either shared or exclusive lock, but the complete table will be held until the transaction is completed. And I think I don't need to write the syntax for each and everything. It will be the same stuff, okay, for all the locking hints. Let me explain the different types of locking hints available. Like I discussed row lock now, update lock now, and now let's see table lock. Table lock, generally it will hold the complete table until the end of the transaction. The next one is page lock. For example, pages, as I told you, pages will have tables, right? This guy will have table, right? And if this particular table is having shared lock, then if I apply page lock on this, then this lock will be removed and only this lock will be present. Why? Because it is setting a lock at page level. Then why you need to have a lock at table level? Right? Generally, page lock replaces a shared table lock with shared pages locks for each page containing qualifying rows. So here in this case, it will be replaced. The table lock will be replaced with the page lock. Why? Because it is the highest granularity, and the complete page will be locked until the transaction is completed. And the next one is X lock. You have X lock here. The pronunciation, the spelling of the X lock is X lock. So generally it specifies the exclusive locks are to be taken or held until the transaction completes. So what is meant by exclusive lock? You are very well aware, right? We discussed about it in last session. This is one of the lock modes. So exclusive lock will be set until the transaction is completed. If exclusive lock is specified with the row lock or page lock or some other lock like table lock, the exclusive locks applies to the appropriate level of granularity. I told you can use multiple locking hints together. For example, if I use exclusive lock with row lock, then row lock will exclusive lock will be set at row granularity. If the exclusive lock is set with table lock, let's say this guy with table lock, then the exclusive lock will be set at tabular level. If I set it at page level, combination with page, then exclusive lock will be set at page level. And if I set this exclusive lock at row lock level, and if I use exclusive lock and row lock parallel in one combination, then the exclusive lock will be set at row granularity. So these are the different locking hints that are available, and there are a couple of things which are not of high priority, like a whole lock, which is nothing but repeatable read lock, and we have a read past, which means if you go for read past, the database engine does not read rows that are locked by other transactions. It will be like it will wait until the other transactions are completed and then it will read the data. So these are the different locking hints that you can set in your that you can make use in your SQL statements. And you can set the lock timeout, or you can find out the lock timeout. It will be like the default one for everything. For example, you can use the global variable to find out what is the locked timeout that is set. That by default value, The default one is -1. That is -1 refers to infinity in general, no time limit kind of thing. Or you can set the timeout. You can set the lock timeout, and this lock timeout is global one. It will be set to all the locks. It's even one. Let me show you how to set the lock timeout. It is a simple set statement in SQL Server. Lock timeout and the value. Let's say I'll set it to 1200 seconds. So if I execute this, now the lock timeout is replaced from -1 to 1200. You can see the lock timeout is modified to the new value. So this is how you can set, and this lock timeout will be taken into consideration from here onwards. And you can also see, this is how you can set the lock timeout. Now let's see how to check whether the locks are present and what is the status of each locks. You can make use of a couple of system tables to get the same data. The system table, what you can query to get the information about the locks is sys.dm underscore, I think it's tran logs. Let me check. And it will be present under system databases. Sorry, system tables. Oops. Sys.tran underscore logs, I think. Select start from. Yeah, this is the table. And you can see it is providing you the information about the logs that are set in this particular database. You can make use of the table, and if you query it in a better way, then it will give you the resource type and what DB. What is the DB, right? In which this particular lock is applied, and you can get the session ID and when it started, what is the status of this. You can see from some status ID as column here. Yeah, request status. What is the status of it, and request type, it is locking type, and the status is still grant. So if you want to read or find out, this is mainly for DBA guys, the guys who works with the data migration or data snapshotting, okay, all those stuff. This table is a useful one, and to find out whether there is any logs happen, and which may lead to deadlocks. So if you just to keep an idea about the table which you can query to get the locking information in the particular database. Now the interviewer will jump into the next concept, that is deadlock. If he decides to query a lot of questions on locking mechanism or transactions, then one of the important one is deadlock. What is meant by deadlock? We already discussed about this deadlock, but with a different name, the concurrency. What concurrency will do? Concurrent users will be trying to access the same resource. When it is happening like this, when there is a situation like you release and this guy needs a resource and this guy needs a resource, the resource that is required for this guy is with this guy, okay, and the resource that this guy required is with this guy, and he can release only this guy releases this resource, and this guy can release this resource only this guy can release. So it might be confusing here. Imagine there are two members, okay, myself and another guy XYZ, and we are accessing a same table in which there are 100 records. I want record number 1, and once I get that, I can finish the functionality and release the record number 2. But the other guy needs record number 2 to release record number 1. That means it's deadlock. He can't release the record that I want until I releases the record. I can't release the record until he releases the record that I want. So this kind of situation is called as deadlock situation. Or you can say it's a special kind of concurrency problem in which two transactions block the progress of each other. It won't allow the progress will not be done, or there won't be any progress just because of the deadlock. Each resource wants the each user wants the resources that is blocked by the another user. So let's see an example for this, how this deadlock occurs and how it can be avoided. Let's discuss about it here. Let me take this picture out. Begin transaction. I'm setting an update statement on dim product name. Update dim product, set product key is equal to 1, where product key is equal to 1001, and I can set some delay. After executing this, wait for delay. I cannot immediately execute, right? It will take very less time, and it will finish all the queries in fraction of seconds, right? So I'm setting some delay. Wait for delay. I'll set it to 10 minutes or 10 seconds. Anything is fine. And I'm updating another record here. I have to set the value, right? And let's say I'll update another record where I'll set the ID to 2, where the record is 1002. So commit transaction. So this is a simple transaction. Let's see the another transaction by the different user. Here he is updating the record 2, okay, with some value, let's say 100. Here he is updating with 200, the record 1. So when these two transactions, if you observe these two transactions very carefully, when these transactions are started at a time, this transaction will be started and this transaction will be started, and it will set locks. This will set lock first whenever it is executing the query, and this will set lock on the first query here, and it will be locked. So this query will be updated and wait for some time, and this guy needs the second record that is being locked here, and this guy has blocked the another record that is required for this. So this is required for this guy, and this is required for this guy. And because of this locking, I mean, if you see that I set some delay, and the SQL server will wait for so much of time, and the records will not be released. These two will not be released until the complete transaction is set, and these two will not be released until the complete transaction is set. This is a deadlock position where the resources required for by both transactions are the same, and both are trying to set the locking mechanism on the resources. So to avoid these kind of things, we will go for proper isolation levels and locking mechanism. Is it clear, guys? So this is very important one. Let's see what happens if I execute both the things. Cannot update. Oh, sorry, I've provided value for the identity column, so that's why it's. Let me take some other guy. I'll take English product name. I'll name it as Rupesh. Here also I'll do the same. For some time, let me remove this transaction. Let me keep it on uncommitted one. So what's happening here? You can see generally it won't take this much time to, I mean, execute, right? So it is not returning anything. So sp underscore who2 will give you the list of deadlocks occur. Which one is locked by which resource? If you see, this process ID is in runnable state, that is selecting to command, and this is in sleeping, and these are sleeping, these are background processes. So here you will get the information. If it is what we call it as deadlock, it will be hang position, and you can find out which one is hanging this particular, which one is leading, which one is the cause for hang, bringing a process ID to hang state. You will find it here. The column for that one is, let me check that, SPID, I think. So which SPID or which request ID, somewhere here, which is blocking the particular process. You can get the information if you execute the stored procedure, system stored procedure SP_who2, generally which gives about the deadlocks or the problems that are in the particular execution, particular database. Execute it here. It will give you some information. Let me see whether it shows this or not, whether it is hanged well. See, suspended, you can see this is suspended, right? And it is suspended by some ID. It will be given that information. So that information will be given. I mean, you can query it by using some other, and it is waiting for. It is in the status wait for, right? And so this is how, I mean, I've taken a very poor example here, I can say. Generally in huge queries or huge stored procedures, this SP_who2 will give you the clear information about which SPID is blocked by which SPID. Okay, or you can get that here in request ID. I guess I'm not pretty sure. I'm not a performance tuner, so I don't have much idea on this. But this SP_who2 will give you good information about which processor is being blocked by another processor. And if it is in suspended or blocked state, then you can immediately, you have to release one resources by killing one stored processor. Let's say two stored processors are running and both have locks and both led to deadlock. Then you have to stop one stored processor so that the other stored processor will get the resources and finish it. Once the second stored processor finishes, then you can trigger the first stored processor. This is the most frequent job that will be done in support projects. There will be some thousands of stored processors running in the support environment. Let's say these two are the stored processors and these two are blocked. Okay, and you can find out by executing this SP_who2, and you will find you have to analyze which one is important at that particular point of time. Then you will stop the other one so that it will get all the resources. It will finish. Once it is finishes, then you will start the second stored processor. So this is about locking mechanism, lock granularities, lock what is that? Lock modes and lock duration, and how to set lock timeout and so on, and deadlocks. So in next session we will discuss about isolation levels and either triggers or indexes or functions. We will cover any one concept along with isolation levels. Why? Because isolation levels is a pretty small concept. So we'll add one more like either triggers or something which fits to the session time.